Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. You're listening to a new episode of Stories from Space podcast, where your host, Matthew Williams, examines the history of human spaceflight, the breakthroughs that revolutionized our understanding of the universe and our place in it, and the brave individuals who work tirelessly to advance the frontiers of our understanding. Knowledge is power, now more than ever.
The authors acknowledge that this podcast was recorded on the traditional unceded lands of the Lekwungen peoples. Hello, and welcome back to Stories from Space. I'm your host, Matt Williams, and today we are capping off our series on megastructures. In our previous installments, we looked at the kind of structures that would be possible, assuming the creators were a Type 2 level civilization on the Kardashev scale. We even dipped into a little bit of thought on Type 3 civilizations. But today, we'll be examining concepts that have been proposed over the years that deal with a Type 1 plus civilization. So essentially, the type of megastructures that could be built by a species that has already mastered its planet, which is to say, according to the Kardashev scale, harnessed all the available energy available to its planet. And while these concepts are not exactly as exotic or fascinating as some of the previous concepts we were looking at there for truly advanced civilizations, Type 2 or Type 3, they are nevertheless very interesting in their own right because these are the types of things that, though they may seem a little bit far off in terms of engineering and so forth, they may very well represent the future of humanity. And therefore, they offer a tantalizing opportunity for SETI researchers to look for similar projects in other star systems. And this has, in fact, been suggested that among the technosignatures that SETI researchers consider potentially viable, that there should also be space made for things like Clark belts, which refers to Arthur C. Clarke, who proposed how in the future advanced civilizations would likely have their home planets surrounded by a belt of geosynchronous satellites, which would be detectable over great distances based on the way it reflected light, which would be visible in any direct imaging studies. And of course, all of this comes back to the whole SETI paradox, where we are looking for indications of technological activity based on what we know works. But it's also a foregone conclusion that given the age of the universe, given the abundance of star systems and galaxies, and the fact that the ingredients for life as we know it are everywhere in abundance, that it is statistically very likely that more advanced civilizations are out there, or at the very least, civilizations that have been around much longer than we have here on Earth. So they would have had the chance to realize more advanced technologies that humanity has not yet validated, tested, etc. But we do have some degree of assurance in that if the scientific principles behind it do work, and we just simply haven't created it for ourselves yet, that chances are somebody else already has. So it's a basic rule of SETI. It's like if you can imagine it, and the scientific principles behind it are sound, chances are somebody else has already done that, in all likelihood, many, many times over. So in that respect, Type 1 plus megastructures on the Kardashev scale, they not only represent a possible vision of humanity's future, but also something that SETI researchers should be on the lookout for, because it helps to narrow the search. By defining the parameters of what these structures, this technological activity would produce, we can give SETI researchers something to focus on, because otherwise it's entirely like trying to find a needle in the cosmic haystack, which of course becomes so much harder when you're not entirely sure what a needle looks like. So in essence, speculating about what advanced civilizations might be doing helps narrow the search. It establishes what the needle would look like, theoretically, thus giving you the ability to look for it. So, having cleared all the caveats and addendums, let's get into some examples of some very cool megastructure concepts that have been suggested that happen to fit in between a Type 1 and Type 2 civilization, hence why I call them Type 1 plus. So this applies to all civilizations that have essentially mastered their own planet and have found ways to harvest all the energy available on their home planet and are now projecting themselves into space and have established a enduring presence there. So the aforementioned Clark Belt is certainly a good example, but examples range far beyond that and just get more interesting the more seemingly far-fetched you get. So to start, in a bit of a chronological and thematic order, you have what's known as a von Braun wheel. And this concept originally proposed by Werner von Braun, the famed German rocket scientist who developed the V-2 rocket for Nazi Germany, but then was recruited to the United States by NASA under Operation Paperclip. He had proposed a number of very, very interesting concepts over the years. And the von Braun wheel, in fact, was one of many ideas he proposed for the human settlement of space, which was featured in a spread done by Collier's magazine in 1957, titled Man Will Conquer Space Soon, and also in an episode of Disneyland's Tomorrowland, specifically the episode titled Man in Space. And in addition to all kinds of spacecraft and illustrations from von Braun's own proposal, called the Mars Project, about how humans could in fact conduct a multi-year exploration program to Mars, it showed a von Braun wheel in orbit of Earth, as well as other key bits of infrastructure, which he believed would be absolutely essential for humanity's expansion beyond Earth. And the concept is really very elegant and simple. You have a rotating wheel station, and this provides, or rather, it simulates artificial gravity. The centripetal force that's generated from the rotation, that ensures that everybody inside is being pulled down towards the outer ring, and therefore will not be suffering from the effects of microgravity. And the concept itself is something that goes back even farther than von Braun in his time. And the first recorded mention of it, like many, many concepts in space exploration and humans in space, it's attributed to Konstantin Tsiolkovsky. And he wrote about using rotation in space stations to create artificial gravity. And that was back in 1903. It was featured in his famous treatise titled Exploration of Outer Space by Means of Rocket Devices. And this was the same treatise in which he presented his now famous rocket equation. And that idea went on to inspire the Slovenian aeronautical engineer Herman Platochnik, who released a book in 1923 called The Problems of Space Travel, the Rocket Motor. And that contained a detailed illustration of a circular space station that would be positioned in Earth orbit, and which, again, rotated to impart artificial gravity. And the concept itself was also featured in the 1968 film 2001: A Space Odyssey, which, of course, was co-written by famed scientist and science communicator Arthur C. Clarke. And we see in that a pinwheel station, which spaceplanes regularly dock with and other spacecraft depart from to go to the moon and beyond. And of course, it has the artificial gravity because, as we see it, it's spinning in space to the tune of The Blue Danube by Jonathan Strauss II. And the concept became even more widely known thanks to the 1975 NASA Summer Study, which was a collaborative effort between the NASA Ames Research Center and Stanford University. And the purpose of this study was to design a station that could be positioned in Earth orbit that was based on current day technology and means. And the resulting design was called a Stanford Torus. And interestingly, the idea of that was also featured in the film Elysium. We see the rich living aboard this station in orbit, which rotates, and not only does that provide simulated gravity for the people in the pinwheel, but it also holds on to the atmosphere, which is otherwise left open to space. The artificial gravity basically keeps the oxygen nitrogen atmosphere stable and prevents it from escaping to space. And next up, a concept that is a classic and really goes back to the early days of speculation and dreaming about humanity's future in space, and it's known as the Bernal sphere. And this idea takes its name from John Desmond Bernal, who was an Irish physicist who's best known for his studies on the atomic structure of crystals and solid compounds, but he was also somewhat of a dreamer and a futurist. And in 1929, he released a book called The World, the Flesh, and the Devil, an inquiry into the future of the three enemies of the rational soul. And in section 2 of the book, he spoke about the challenges of humanity going out into space and what it would take for humans to live and work there in a sustainable long-term manner. And one of the ways he addressed this was he suggested the creation of a hollow spherical space habitat that would be pressurized and could accommodate 20 to 30,000 people, and it would measure roughly 16 kilometers or 10 miles in diameter. And as he described it, imagine a spherical shell 10 miles or so in diameter, made of the lightest materials and mostly hollow. For this purpose, the new molecular materials would be admirably suited. Owing to the absence of gravitation, its construction would not be an engineering feat of any magnitude. The source of the material out of which this could be made would only be in small part drawn from the Earth, for the great bulk of the structure would be made out of the substances of one or more smaller asteroids, rings of Saturn, or other planetary detritus. So, like many early theorists, he proposed that space structures could be manufactured using in situ resource utilization. Basically, harvest materials from near-Earth asteroids or elsewhere and use that to build up infrastructure in low Earth orbit or beyond, cislunar space, or even further. And this brings up another major proposal, which is Gerard K. O'Neill's O'Neill cylinder. It is said that he was partly inspired by the Bernal sphere, and much like with the Stanford Torus, it began with a study in which he and students of his began working on the idea for a space station that could accommodate thousands of human beings away from Earth and could be manufactured using in situ resource utilization and could be accomplished using then current technology. And it was during the 70s this study took place. And he detailed it further in his 1976 book, The High Frontier, Human Colonies in Space. And he described how humanity could expand through the solar system using these stations, or as he'd like to refer to them, islands in space. And as he said, although the total volume of the asteroids is far smaller than Earth's, it is a volume much more accessible than the depths of our planet. On Earth, only a thin skin of material is available to us without deep mining under high pressures and intense heat. We would have to disfigure the entire Earth to obtain only 1/100th of the material contained in these now useless, lifeless asteroids, and there are thousands of those minor planets. So, by mining out asteroids, he conceived of how people could create a long cylinder that would measure 32 kilometers long, or 20 miles, by 8 kilometers in diameter, or 5 miles, and the full length of this would actually consist of 2 cylinders, and they'd be counter-rotated. And this would simulate gravity for the inhabitants, and at the same time, the counter-rotation would cancel out any gyroscopic effects, meaning that it would not begin to veer or change direction there over time, and this would keep it aimed squarely at the sun in his proposal. And according to O'Neill, The main purpose of these habitats would be to relieve population pressures on Earth. And that at the same time, they could be positioned throughout the solar system at various Lagrange points. So they would have a stable orbit wherever you place them. And eventually they could accommodate millions of people and without the need for settling on other planets. And that's especially important when it comes to space habitats because, of course, settling on other planets requires some significant engineering. You need habitats that can protect against radiation and also an unbreathable atmosphere, or in some cases, no atmosphere. And of course, there's the issue of lower gravity, which means that people living there would be subject to health effects over time, and we're not even sure how it would disrupt reproductive cycles. So if we're planning on creating self-sustaining populations in these places, i.e., they're going to make babies, we would need to know exactly what kind of intervention was necessary to ensure that they grow and develop healthily. And as he envisioned it, it would actually allow Earth itself to become something of a preserve, because not only would the human population be able to relocate to these space habitats largely over time, but industry could also make the migration. Mining, as he explained, it could be done at a fraction of the cost and with far less effort when it comes to asteroids, and also manufacturing. Done in space and in zero gravity, you could take advantage of that for all kinds of processes. So basically, you could cease all mining and all manufacturing on Earth. And as he described it, a non-industrial Earth with a population of perhaps 1 billion people could be far more beautiful than it is now. Tourism from space could be a major industry and would serve as a strong incentive to enlarge existing parks, create new ones, and restore historical sites. So, with a population just 1 billion, which is something that James Lovelock advocated for, he's the author of Greening Mars and the co-inventor of the Gaia hypothesis. A population of 1 billion is believed to be what would be perfectly sustainable for humans and Earth without any environmental destruction needed to provide for them. And of course, with this population reduced to a fraction of what it is today, Earth's natural habitats and biodiversity could restore itself. And it's also worth noting that the O'Neill cylinder is something that Jeff Bezos, also a futurist who is hoping to create a road to space there so that we can have a much larger human population that lives largely off-world, he is an advocate for creating O'Neill cylinders. So in the sort of competition between him and Elon Musk has been dedicated towards settling Mars for certainly before he founded SpaceX in 2000. Bezos has been dreaming of building islands in space. But of course, the two of these gentlemen, they're not alone in this, and they are not representative of the actual advocacy and field. They're just two of the best known names. And of course, I'd be remiss if I didn't point out the way that this idea was explored in science fiction by Arthur C. Clarke in his novel Rendezvous with Rama. Rama, as we learn from the story, that's the name that human astronomers give to this large, very large alien spacecraft that is passing through the solar system, which is a giant cylinder. And the rotation of the cylinder is what imparts gravity to all the inhabitants, although I don't want to give too much of the story away. But yes, the ship seems largely uninhabited when the human astronauts arrive and begin exploring it. And yes, it also is consistent with O'Neill's descriptions there. It has these long trenches that are windows to the outside that emit sunlight, and you have an entire world, an entire ecosystems and cities and so forth built into the interior for a population to live. And another good example is the show Babylon 5. You have this massive space station in neutral space that's a protocol for diplomacy and so forth, and it becomes the center of this really epic galactic story and major war and so forth. And the station itself, it is basically a giant cylinder-shaped object. orbiting a planet, and that imparts simulated gravity for the inhabitants, and there's quite a bit of attention to those little details in the show, so it was really quite good. And another concept that is a bit closer to home and is not dissimilar from a Clark belt is the space elevator. And like most of the time-honored futuristic ideas for humans living in space, this one also goes back to Konstantin Tsiolkovsky. And it was in 1895 he wrote a paper on the possibility of this. He had witnessed the Eiffel Tower. And so he conceived of a structure that would reach to geostationary orbit, roughly 36,000 kilometers above Earth's surface, just over 22,000 miles. However, he envisioned a compression structure. So basically, a structure that had a very, very wide base, and like the Eiffel Tower, each level was a little smaller and supported the overall structure. And at the time, he did note that this was not a realistic idea, given that there was no material strong enough to support the weight of such a structure, but that future generations may find a solution. And this is something that has been with space elevator concepts ever since. Nevertheless, he envisioned this structure as a way for humans to reach space using not rockets, but just a large enough elevator type construction. Even though building a structure would be prohibitively expensive, once it was built, humans would be able to send payloads to space rather easily, or rather cost effectively. Not only would the lifting capacity be greater than what rockets can achieve, but you wouldn't need thousands of tons of propellant in order to launch payloads that vary from a few hundred kilograms to a few tons. But by the onset of the space age, the idea achieved new life as a suspension structure. So instead of building an elevator of one layer on top of the next, all pushing down into the Earth, this idea for a space elevator would be kept in orbit by centrifugal force, Earth's rotation. And the earliest known example came from Soviet engineer Yuri Artsutanov, and he wrote in 1959 a proposal for an electric train to the cosmos. And by 1966, a team of American scientists had independently stumbled upon the idea too, but they referred to it as the skyhook. In any case, these and other versions that would follow, they shared a lot of the same design elements. So you'd have, for example, an anchor, which would be attached to a fixed point on land or a mobile sea platform, a tether that extends out from Earth into space, and a counterweight at the other end in space, which could be, in many designs, a captured asteroid. And in between that, you'd have a space station that was positioned right around geosynchronous orbit, or in some versions, the station itself is the counterweight. And then, of course, you have a series of cable cars or climbers that would regularly travel along the tether, delivering crews and payloads to orbit, and these could be powered by any number of methods, ranging from solar panels to nuclear reactors or direct energy transfer along the tether. And the idea has also been popularized in science fiction by Arthur C. Clarke, and he even spoke about it before Congress. In any case, the most well-known example of Clarke's advocacy for such a structure was in his book Fountains of Paradise, which featured a space elevator, which was anchored in the Maldives in the Indian Ocean, which happens to be a perfect spot there to create an anchor structure for the space elevator because it's equatorial, and also it's not far from where Arthur C. Clarke lived the better portion of his life in Sri Lanka. And other locations that I've personally looked up are Isla Isabela, which is off the coast of Ecuador, and Sao Tome and Principe, islands off the coast of Equatorial Guinea and Gabon, Africa. And the idea has received a lot of fresh thinking and ideas ever since the turn of the century, thanks to the development of carbon nanotubes. And even though those were judged to be not a decent material for a tether ultimately, there is a lot of new life being breathed into it now, thanks to the discovery of graphene. And listeners may recall an interview I did with Dr. Peter Swan and Adrian Nixon, both of whom are members of the International Space Elevator Consortium, and we discussed exactly that, a graphene tether that could make a space elevator a reality, and they've since been investigating other materials as well. The point, however, is that a structure of this nature would be a good example of a Type 1 plus civilization, the kind of engineering that they'd undertake, and it would be detectable, too. Provided your instruments are sharp enough and you can do direct imaging of exoplanets, which we are starting to do ourselves, if you can finally assess the light being reflected from an exoplanet, if you're capable of discerning a Clark band, well, then you will surely be able to discern the presence of the large counterweight and the space station that connected to the surface. What might appear like small orbital asteroids, not unlike Mars's moons Phobos and Deimos, would in fact actually turn out to be, given their perfect co-rotation with the planet that they're orbiting, they would in fact appear to be a space elevator or a like-minded structure. But of course, the list doesn't end there. There's also the notion of orbital rings, which was featured in the miniseries adaptation of the Foundation series by Isaac Asimov. And curiously enough, in that show, as I recall, Trantor, the capital of the Empire, it had a space elevator which was then sabotaged. So instead of building another space elevator, they decided to build a series of orbital rings. So similar in concept to a Niven ring, but also with a little space elevator engineering thrown in there. You'd have a series of rings in geosynchronous orbit or in low Earth orbit, perhaps. The actual height specifications can vary, and they are connected to Earth by a series of towers. And this idea was also featured in 3001, Final Odyssey, Arthur C. Clarke's final installment in the whole Space Odyssey series. And the idea being that humans would have quick access to space. They could ascend from any one of a number of elevators positioned around the globe, because, of course, this massive megastructure here, it would have to be anchored to several points on the globe, and again, equatorial locations are the best. So one in South America, specifically you have Ecuador, Colombia, or northern Brazil, and also Africa, anywhere from Gabon to Democratic Republic of Congo to Uganda or Kenya, southern Somalia, and then Indonesia or Borneo, and ultimately somewhere in the Pacific Ocean there. So possibly the aforementioned Isla Isabela. So these and other concepts, and believe me, there are many, many more. And once again, I got to recommend Neil Blevins' artwork. He has assembled a very impressive montage of different concepts there, and he's done artwork for each of them. But this provides a pretty good framework here for not only the kinds of megastructures that are consistent with a Type 1 plus or Type 2 civilization, or a few ideas there I'd mentioned for Type 3, a galactic civilization, but I do believe you'll find that these many, many different ideas that you can find out there are variations on a few core concepts. So, for example, Type 2 megastructures are almost all derived from the Dyson sphere concept, and so they fall under the heading of Dyson structures. And that certainly can include Niven rings, because they are, as Niven admitted, it's his own take on a Dyson structure, and they're often referred to as Dyson rings. And as for Type 1 plus megastructures, yeah, they really come down to pinwheel stations, aka von Braun wheels or Stanford toruses, or tori, as well as space elevators, Bernal spheres, or O'Neill cylinders. They tend to fall into certain groupings, just based on general theme and engineering challenges. But before we wrap up our series here on megastructures, I had to mention one in particular that I completely forgot, and I was very saddened to realize I had, because it is another exotic and one of my absolute favorite ideas, and it's also one I want to feature in a fictional story at some point, and it's known as a nickel Dyson laser. And this idea comes to us from a science fiction reviewer named James Davis Nichol, and it's based, of course, on a Dyson structure. And in his idea, it's a little bit like a Shkadov thruster in some ways, in that you have a megastructure that is surrounding part of a star, and the idea is to focus its energy, but instead of propulsion, you're using it as a gigantic laser. So you've got, in the Neil Blevins concept that he illustrated, it shows a bunch of focusing megastructures as well as lenses and Dyson swarms and other structures hovering around bound to the sun's gravity that are there to ensure that the sun's energy is all focused down to one single point, which is then emitted towards a target. And that target could be anywhere, it could be just about anything, because you could conceivably hit a target hundreds, thousands, or even millions of light years away. So essentially, it's a giant version of the Death Star, or also a giant version of the Star Killer base in the Star Wars sequels. However, I dare say, compared to Star Killer base, it's slightly more realistic. Once again, as Dyson pointed out, as long as the physics are sound, then it can be done, assuming you have the requisite technology, time, energy, resources, etc., etc. So if the Death Star can be compared to a moon and Starkiller Base is a planet, then this would be the Death Star on a stellar scale. And hopefully nobody in the Star Wars franchise thinks to develop that into fiction because, well, let's face it, there's only so many times you can go to that well. And because, frankly, I'd like to beat them and anybody else to the punch if I can. So, in summary, that is everything that I could possibly relate on the subject of megastructures, crammed into 3 episodes. I certainly hope people have enjoyed listening to this as much as I've enjoyed writing about them over the years and learning about as much as I possibly could about these so far entirely theoretical structures and how they could be a techno-signature that could point the way towards extraterrestrial intelligence. And of course, one of the very exciting notions, if ever we did find examples of megastructures out there, if, say, dimming stars like Tabitha's star, or disappearing stars, which is another phenomenon where stars were no longer detected where previously they had been apparent in astronomical surveys, if any of those could in fact be attributed to a giant artificial structure, well, it would then be incumbent upon us to determine, is there any other technosignatures coming from it? Do we hear any indications, or see any indications too, of radio or optical transmissions or what have you? Is there any sign of activity going on there? Because, as we may come to learn, whoever built that is no longer there, which then, of course, creates the awe and mystery of what happened to this once very, very grand civilization. Did they eventually go extinct? Have they evolved to some other form of existence where they no longer require physical structures of this kind? All very, very fascinating stuff, and stuff that really just lights the imagination on fire and is a goldmine for science fiction writers and fans thereof. And as I said, I hope to write about these ideas in fiction at some point, because I certainly had a lot of opportunities to write about them as a matter of scientific and real life SETI speculation. In any case, Stay tuned for more upcoming episodes, which will include an episode, as I've promised for a very long time, on the web naming controversy, as well as some of its more recent findings, and per a request I got, another look at the state of NASA right now, which is, to put it mildly, very chaotic and disappointing. There is a very real assault on public institutions right now in the United States, and it doesn't really matter what their purpose is, but it does seem like science is being singled out, especially where earth science and environmentalism is concerned. But not just that. And we'll have a look at all of that in an upcoming episode. And of course, as always, I plan to have more guests on who are going to talk to us about what's going on in space today and the exciting possibilities, what lies ahead, and other topics related to space, our exploration thereof, our study thereof, and the history of it all. In the meantime, thank you for listening. I'm Matt Williams, and this has been Stories from Space.
We hope you enjoyed this episode of Stories from Space podcast with Matthew Williams. If you learned something new and this podcast made you think, then share itspmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.